All right, so what I'll do here is give an overview of the skeletons for assignment 2A. If anybody has any questions, feel free to jump in. Let's go ahead and start first by taking a look at gazing simulation activity. This activity is very similar to the one we have used in the past. Basically, this is what gets launched after a person types in the various counts that they want for the Palantiri activity. This would include things like the number of Palantiri they want to have, the number of beings, the number of gazing iterations, and so on. And when the person clicks the button there, that goes ahead and starts the gazing simulation activity. We've looked through these methods before, so I won't go through them in detail. There are a few things I want to draw your attention to, however. If you take a look down here, you'll see that there's a bunch of methods called mark Palantir, mark being, and then there's specific things like mark free, mark used, mark idle, mark interrupted, mark gazing, mark waiting, and so on. And these are the methods that you'll be calling inside of your being async task file. And you'll notice if you were to go back and look at the earlier implementations, these returned a different value, or maybe didn't return a value at all. Now what they do is they return a runnable. So you'll see mark waiting returns a runnable, mark gazing, mark interrupted, mark idle, and so on and so forth, and mark free. And you'll be making these method calls in being async task inside the loop that's doing the main gazing. So we'll take a look at that when we get a little closer. But the main thing to notice is that these methods now return a runnable. Otherwise, everything else is pretty much the same. Let's go take a look at Palantiri presenter. Oh, wait, before we do that, let's go take a look at the model. So the model layer has you basically use your same implementation that you did for assignment 1C for the Palantiri manager. You're welcome to use that implementation. Just make sure it works before you try to use it. And so you'll have to fill in the constructor and the acquire and the release method. And then you'll also have to provide your simple semaphore implementation that you used for assignment 1C. So that should look essentially the same as you did before. We will be modifying assignment 1. The model layer part of this will get modified later in the assignment 2B part. But for right now, we're keeping it pretty simple. All right, let's now go over take a look at the presenter layer. Here's the Palantiri presenter. So a lot of this looks the same as before. There are a few differences, of course. So now we're going to have a list of being async tasks. We'll talk about what a being async task is in a second. We're also going to have a thread pool executor. You'll have to implement both of those things. Then down here, you have to implement something called a thread factory. And you'll basically replace the return null with something that makes a new thread each time it's called. Down here, we've got the constructor for Palantiri presenter, which does some work. You don't have to implement that part. Here's the onConfiguration change method. You don't have to implement that part. A lot of this stuff is already done for you. Let's go down to where you actually have to do some work. So here's the start method. This is the method that gets called back when the Palantiri presenter needs to start running. It goes ahead and shows the beings and shows the Palantiri after initializing them. And then there's two method calls here, begin being tasks gazing and await termination of thread pool executor. You have to fill in the implementations of both of those methods. So let's go take a look here. So here's begin being tasks gazing. As the name implies, what you'll need to do there is create a new array list that will store a being count number of being async tasks. And then you have to go ahead and execute all these tasks in a custom thread pool executor. And so you're going to have to make the custom thread pool executor. And that executor will have a fixed size number of threads corresponding to the number of beings, a linked blocking queue to queue things up, which you won't really have to do in this case because you'll have enough threads, and a thread factory instance, which was allocated before. So that's basically what goes on there. You'll have to go ahead and create the array list of being async tasks, and then go ahead and kick everything off using the executor. And then once those things are up and running, each of them will have its own thread because you'll have being count number of threads. What you do here is you'll have a method called await termination of thread pool executor. And what this does is this spawns a new thread, and in the thread's lambda expression, which is started down here, you'll go ahead and await the termination of the thread pool executor. So that's basically going to block waiting for the thread pool executor to be shut down. We'll talk about how it gets shut down later. And then, of course, once it's all done, then you go ahead and tell the UI thread that the simulation is finished. Here's the shutdown method. So the shutdown method, unlike previous implementations of this assignment where shutdown was called under abnormal circumstances, in this case we're going to have it be called either under normal or abnormal circumstances. And the way you tell which one it is whether or not the Boolean parameter says abnormal shutdown. So if it's an abnormal shutdown, we're going to have to tell the user that it was shut down abnormally. But otherwise, it does basically the same thing. The first thing it has to do when it gets shut down is it cancels all the remaining being async tasks, and then it goes ahead and it tells the executor service, the thread pool executor, to shut down immediately. So shut down right now. And that will then go ahead and cause this method that's blocked here to return. So that's how you basically get out of the waiter thread when it's done. So of course, the whole thing here hinges on how shutdown now is going to get called. And we'll take a look and see how it gets called under different circumstances. So that's basically what you have to do for the Palantir presenter. Yes, Jesse?
Why is the abnormal shutdown, why is shutting down the view mean that it was an error?
Oh, good question. So the question here is, why is shutting things down an error? Well, it depends on why things get shut down. So things get shut down under two circumstances. One reason why things get shut down is that you're done. So all the final thread, the final gazing thread is finished, and then we shut down, and that's a normal shutdown. So we're just happy in that case. We don't print any error messages or dialogues. There's some other situations, however, where it's shut down abnormally. So a good example would be if there's something wrong with your semaphore implementation and there's too many threads running, then there's a check inside the code that checks to see whether or not the threads exceed the thread count, the expected number of count. And if it exceeds it, we want to shut it down abnormally. So that's one way things get shut down. Another way things get shut down abnormally is if somebody clicks the interrupt button. There's an interrupt button on the display that causes the program to shut down. So in that case, we want to basically pop up a message saying we've shut down because of an exception or whatever. So that's considered an abnormal shutdown. And I'll show you some examples when we look at the being async task about how it controls whether it's normal or abnormal. And it's just a matter of what parameters passed in, whether it's a Boolean true or false. All right, let's go take a look at being async task. So here's being async task. Being async task extends async task, and it has the three parameters. It has the params that are passed to do in background, which is a Palantir presenter. It has a runnable, which is passed as the progress update. When you publish the progress, the onProgress update method takes this parameter. And then there's also the third parameter, which is what's passed to onPostExecute. So those are the three things that are passed here. Let's take a quick look. So you can see we keep track of the number of gazing tasks. This is used for two purposes in this assignment. One is for a sanity check to make sure your semaphore is working properly. And the second thing it's used for is to determine when the final thread has stopped gazing. And this is really important. It's subtle and tricky, and we'll see how it gets used later. Here's the being count. That's also an atomic integer. And that just keeps going up and up and up, and we mod it. You'll see how it gets used. Here's the being count. Every time we get a new async task, we increment the being count by 1. Every time somebody calls get being ID, we take the current count and we mod it by the number of beings so it stays within the range that we're expecting. Here is the do in background method. So this is the method that you'll have to implement a portion of. You can see do in background is basically going to be doing the gazing iterations. So do in background will run in a background thread. That's the way that the async tasks work. This is running in a background thread, and we're going to go ahead and iterate for the number of iterations, calling gaze into Palantir, passing in various things. So that's how we get stuff up and running. That's kind of like the run method we had before in the previous implementation, except now we're using an async task. Here's gaze into Palantir. You'll have to put in a check here to make sure that whether you've been canceled or not. It's kind of like being interrupted. There's a special method you have to use for an async task for that, however. And then down here, now we get into the interesting part. So you'll see there's lots of to-do methods here. After you do a sanity check to make sure that you were really supposed to get a Palantir, what you're going to have to do here is go ahead and well, let's see here. Oh, yeah. OK, so here's a good example. You have to go ahead and call the appropriate method to indicate that you're waiting. And so you'll have to take a look, and remember the key to know how to do this is that those various methods like mark gazing, mark free, and so on, those are all returning runnables now. That's the secret sauce to remember. And you have to make a bunch of these different calls. So these are the calls that are going to be used to go ahead and get the results of them to run appropriately in the UI thread, because we're coming up with a way to mark the UI thread with the right color of the dot. So you fill in those to-do methods. You can gaze into the Palantir for the allotted time. We release the Palantir manager. This code you already know how to do from before, so we're not going to worry about repeating it here. Now here are a couple of interesting methods. This is the onProgressUpdate method. This is the method that gets called back when progress is published. So in the doInBackground thread, when you call gaze into Palantir, whenever you want, remember this is running in the background, so whenever you want to communicate something from the background thread to the foreground thread, to the UI thread, you have to publish the result. And that result is going to be the result that's returned by those helper methods that are in the gazing simulation activity class. And so you'll make the calls, and those things will then end up causing onProgressUpdate to be invoked. And onProgressUpdate gets a variadic argument of runnable commands. All you care about is the 0th one. The other ones are irrelevant. And so you'll want to be able to display the result that was passed in here. This turns out to be really, really easy to do, but you have to think about it. You have to think about what you're getting here and what is it going to be needed to be done to get it to display the progress update in the UI thread. So look very carefully at gazing simulation activity, and then look at this and think about what you're getting back to figure out what to do. So that's one thing. It's very simple, but it takes some thought. It's very, very simple. Do not be doing complicated things in onProgressUpdate. It's really, really simple. OnPostExecute and OnCancel. These are the hook methods that are called back when the async task object either completes successfully, in other words, doInBackground completes successfully, or doInBackground is canceled. So if doInBackground completes successfully, OnPostExecute gets called back. If it gets canceled, OnCancel gets called back. These two methods both are going to do the same thing. We just have to separate them out. And what you're going to do here is, if this is the final task that's gazing, if there's no more tasks that are gazing, then you're going to shut down normally. And remember, we talked about shutting down normally, where you call shutdown, and you pass in false, because false means false abnormal shutdown. So the Boolean is abnormal shutdown. Here we're saying we shut down normally, so that makes it false. And you're going to have to figure out how you know when this is the final gazing task. And so the trick is to look around at the other fields that are part of the being async task and figure out which one will tell you that, and then make sure that is called properly. Then down here, you'll have to implement increment, gazing, count, and check. And notice that if something goes wrong here, then you call shutdown. And in this particular case, shutdown is going to be passed a parameter of true if something goes wrong, because that means we're shutting down abnormally. So those are the main issues. And you'll have to implement the gazing, count, and check. You can probably reuse most of your code from before. Just have to make sure you pass in the right parameter to shut down, since that's changed. And same thing for decrement, gazing, count. So those are basically the methods that you'll have to implement. It's not really hard, but it takes some thought. So I strongly recommend that you take a look at the index.html file, and the index.html file that goes along with this particular application includes the links to various videos that will give you the information you need in order to figure out how to do async tasks and how to do thread pool executors. Of course, we will go over this in class at some point as well, but if you want a head start on that, go ahead and take a look at what is in those videos.